Hi, I'm Chem's best friend and welcome. Please like and subscribe to my channel. And if you would like to contact me, the information is on the bottom of your screen. So let's learn more about VSEPR. In a previous video, we went through all the rules and we learned some simple, easier structures, how to predict the 3D shape of molecules. And in this video, we're going to just go a little bit harder, a little more complicated structures, and I think you're ready for it, don't you think? So let's go to my screen. A quick review. We learned about electron domains, that we have a single pair, single electron pair is considered one electron domain, single bond, double bond, triple bond, each are considered one electron domain, and then a lone electron, very sometimes you will see that, not often, is also classified as one electron domain. We learned about all the rules, how to predict the shape, and we also quickly got a little cheat sheet with all the names of electron domains, and also if you have lone pairs and the name of all the molecular geometries. So let's keep going. Let's practice. So here we have I3 minus. Let's do a Lewis dot structure for this. Are you ready? So iodine is a halogen, 7 valence electrons. So we have here 3 times 7. And remember, we have this right here, a negative, our polyatomic ion. We have to add one electron. So we have 22 valence electrons to deal with. Let's put our iodine I, let's put it in a line, and 2 electrons for each bond, and our octets from outside in. So 16, and any leftover ones go on a central atom, right? This is from our Lewis dot structure, 16, so 17, 18, 19, 20, 1, 2. I'm going to just a little bit, do a small little highlight on them, just to make sure you know these lone pairs. Okay, and also this is a polyatomic ion. We need a bracket. We need a bracket for it, and here we go. So let's do our shape of this molecule. So let's count our electron domains. How many do we have? Well, here is 1, 2, 3, 4, 5. We have 5 electron domains. It's getting a little harder, right? So we have 5 electron domains. So my electron domain geometry is, do you remember? It was that 3, trigonal planar, and then one sticking up, one sticking down. So we have trigonal bipyramidal. Trigonal bipyramidal. Yes? So we are right here, 5 electron domains right now, trigonal bipyramidal. Okay, let's draw it. Let me show you how to draw this. So we're going to stick the central iodine right in the middle. And then I'm just drawing 5 electron domains. So one will be on paper here, and one will be sticking out. And one will be going in. Now these guys will be all on the same plane. I want to just kind of draw this like this. See, they will be all on this same plane. All right, and then I'm going to have 1 electron domain going straight up, 1 going straight down. So here's my 5 electron domains, and I need to place my lone pairs. Now, the ones which are on the same plane, these, you're going to think of them like they are on the equator. They are called equatorial positions, and these are called axial positions. And the reason trigonal bipyramidal is the hardest, I think, shape of molecule is you have 2 different angles, and you need to know where lone pairs go. So lone pairs go on equatorial positions. You have to fill them in first. So I have 3 lone pairs. So I have 1, 2, 3. 3 lone pairs go here, and then my other 2 iodines, 1 of them goes here, 1 of them goes here. So now the degree angles, let's think about degree angles. So between these and every single one lone pair is 90, but I don't see it. But this is 90, but the lone pairs, I don't see it. So then between each right here, between these two iodines, is 180 degrees. So my molecular geometry is linear. Do you see it? This is why this is a little harder than the previous video. All right, let's go here. Here we have XeF5 plus, and you say, wait a minute, isn't xenon our noble gas? And doesn't noble gases don't like to react? Well, the thing is that xenon is one of the bigger, really big noble gas, and in a lab, you can make it react. So let's count our valence electrons. We have here 8 plus, oh my gosh, 5 times 7, minus 1, right? Minus 1. So it's like 6 times 7. So we have our 42 valence electrons to deal with. Wow, that's a lot of valence electrons. Are you ready? So let's draw it. Here is our xenon, and we're going to do 5. 1, 2, 3, 4, 5, and let's do 2 for each bond. Yes, and then octets from outside in. Let's keep going. Okay, and when I'm done with this, I realize I used 8 times 5, 40. I'm going to have to put a lone pair here. I am going to highlight it just so it doesn't get lost, so you can see that it is here. And it's a polyatomic ion. I need my bracket. Yes, the plus side. This wasn't very graceful, but the lines. Okay, here we go. So let's go through this. We have how many electron domains? We have well, let's count. We have 1, 2, 3, 4, 5, 6. Do you see it? We have our 6 electron domains. 6 electron domains. So my electron domain geometry is octahedral. And let's draw it. And the way we draw this is you're going to put Xe, and when we draw it, 2 as going to be sticking out. 1, 2 as sticking out right towards you, and 2 are going behind. So these guys are going to be all on the same plane. And when one is on a paper and this is on a paper, and we're going to usually, it doesn't matter where you stick your lone pair, but I like to stick it on the bottom. And then we draw our fluorine. And the degree angle between every single one of them is 90 degrees. Right? So now my molecular geometry, what will this molecule look like? Well, it's going to look like just like the pyramid in Egypt, right? So it's going to be square, pyramidal. Right? And if you want to draw the final structure, you can just then erase the bottom lone pair, the electron domain, and you have your final structure. How is that? All right, let's keep going. When we have here's NS2 minus, and I'm quickly going to count the valence electrons, and we have 5 plus 2 times 6 plus 1. We have 18 valence electrons, and I'm going to quickly do this. Here is my nitrogen, here is sulfur, and octet 16, 17, 18, and oh, I have resonance, right? I have this is my one choice or this choice, one or the other, and they are both sulfur, so it's the same equal choice. So here is my resonance, and I need to put a bracket, but here is the thing. Again, thought process. What does this remind you? Well, this reminds me like ozone molecule. that we had in a previous video. Very, very similar. So we can draw quickly our shapes. Here is one of them, and our arrow, and the second choice was another possibility is right here, bracket, and then we're going to use one of them for our VSEPR. So let's count. We have 1, 2, 3 electron domains. Yes. So my electron domain, so I have 3 electron domains. Electron domain geometry is trigonal, planar. Planar. Let's draw this. So we have, here is nitrogen, 3 electron domains, and here is my lone pair, and then sulfur here, and it's going to be, well, trigonal planar, it's going to be 120 degrees apart. So my molecular geometry is going to be bent, and the degree angle, remember you have to write which bend. It's the bend with 120. How are we doing? All right, I think so. Let's keep going. Here we have a little bit harder, SCl4. Let's go. So sulfur comes with 6 valence electrons plus 4 times 7. We have 34 valence electrons to work with. So here we go, sulfur, and then we're going to put chlorines on the outside. And let's do our 2 for each bond, right? And octets from outside in. So I'm using 8 times 4. I used up 32, and then 2 more. I do want to highlight them to keep in mind that this is my lone pair right here. So let's count out the electron domains. 1, 2, 3, 4, 5. 5 electron domains. Yes, so 5 electron domains. So my electron domain geometry is trigonal bipyramidal. And remember, that's the hardest one. So let's go through this again. So here we're going to draw sulfur and 5 electron domains. So 1, and this one will be sticking out. This one is going in. They are all on the same plane. And this is going up, down. And remember, these ones are my equatorial. And these are my axial. Well, hold on. These are my axial. And my lone pair has to go on equatorial. I have one lone pair. My one lone pair I'm going to stick right here. And then my chlorines go here. Degree angles were between these ones is 120. And then between every one of these is 90. And if you take this molecule, so here it is, yes, here it is, and let's take one of them away. So it's there, it takes up space, but you cannot see it. Then you put it on a side. Do you see? It looks like a little seesaw. The green are the seats for the kid. So it's, yeah, do you see it? Hopefully you see it. So my molecular geometry, oops, I would like a black color. So my molecular geometry is seesaw. Here we go. How is that? Let's go a little bit more. A little bit more. Here's our chlorate polyatomic ion. Yes? Let's, so we have 7 plus 3 times 6 plus 1. We have 26 valence electrons. Let's put in now. You say, wait a minute. Chlorine is a halogen. Doesn't it want to be on the outside? Yes, but oxygen is more electronegative. Remember, you stick your more electronegative elements on the outside. Right? So we're going to quickly 2 for each bond. Then octets from outside in. Yes, so I used up 24, then 5, 6, bracket. And there we go. Let's count our electron domains. Yes, we have 1, 2, 3, 4. Yes, 4 electron domains. So here we go. 4 electron domains. Electron domain geometry is tetrahedral. Let's draw it. Here is chlorine and 4 electron domains. 1, 2, 3, and 4. And my lone pair you can stick anywhere. I usually like to stick it here. And here is my oxygens. Remember, it's 109.5 minus 2.5 for each lone pair. So 107, 107. So my molecular geometry is trigonal pyramidal. And it's 107 degrees. All right, let's go here. Here's a little bit harder. NO2, nitrogen dioxide. Notice there is no charge on this. So many people really want to put a charge here. Don't put a charge if there isn't. This is nitrogen dioxide. It's a poisonous yellow gas. Sometimes it's emitted from our cars. Not a nice gas to breathe in. It's actually fatal. All right, let's do this. So we have 5 valence electrons plus 2 times 6. We have 17 valence electrons. All right, we have nitrogen here, oxygens here. We're going to do our octets. Okay, 16. And then I have to put that one here, 17. So I have odd numbers of electrons. I gotta deal with it. And I also don't have an octet on nitrogen, so I can either move these guys down or these guys, right? I cannot do both. Nitrogen cannot have more than 8. Remember, it's in a second energy level. So it's one or the other. So I do have resonance, but it's going to be then a lone pair. Here is my one choice. Or here is the other choice. I mean the lone electron, not the lone pair, right? It's the lone electron. And here you go. So I chose this molecule because most students fall apart. They see one electron and it's a little panic. What do I do? Well, you're going to treat it as one electron domain. Okay? So here is 1, 2, 3. 3 electron domains. All right? And now hopefully you're like, okay, I know how to deal with 3 electron domains, right? We have 3 electron domains. So my electron domain geometry is 3, so trigonal planar. And if I do 3 electron domains, and one of them is right here, but electron, and then this one is oxygen here, you can quickly see that the final molecular shape geometry is bent. And again, which bend? 120. All right, we're almost there, almost at the end. Are you ready for the last one? Last one, ClF3. All right, the more electronegative element is fluorine. We will stick fluorine on the outside and chlorine in the middle. So let's do this. Count our valence electrons. And it's, well, we have 7 plus 3 times 7, 28 valence electrons to deal with, right? So let's go here, 2 for each bond, and then octets. 24, 5, 6, 7, 8. Yes, just going to quickly highlight these to make sure you notice that these are my lone pairs. I don't need brackets. There's no charge. So we have, again, how many electron domains? Let's count. We have 1, 2, 3, 4, 5. Yes, 5 electron domains. So we're going to end with the hardest, right? So electron domain geometry is, remember, trigonal bipyramidal. So here we go. Cl, 5 electron domains, 1, 2, 3, 4. Let's make this coming out, and 5, this is going in. And where does lone pair go? Lone pair goes on equatorial. We will stick lone pairs here. And now fluorines we will stick here. And hopefully you can see that between these fluorines is 90 degrees and 90. So my molecular geometry is, well, take this molecule right there. So there's two things here that I cannot see. Move it to the side, and it looks like a letter T. So my molecular geometry, we call it T-shaped. And there you go. So I think you're on your way to predict the shape of any molecule. You really have a background, you know how to do it. So thanks for watching, and see you next time.